Hello guys, welcome back. In this video, let us understood in a clear manner the ML lifecycle as well as GenAI lifecycle. So both are seems to be similar, but while implementation coming to selecting a model, they may be varied. This all starts with first business problem. First, we'll consider our business problem. Based on our business problem, we will first analyze our business problem. Then we will really understood, do we actually require any ML model to fulfill our business requirements, or do we actually require any GenAI model to fulfill our requirements, to achieve our business goals, to perform our tasks? So those all we will identify. If we actually require any model to perform certain tasks for our business problem solving, then we will frame the problem statement related to what type of model that we require. We will frame, then we actually frame. If we actually require a ML model or GenAI model for our business problem, then we actually frame the problem statement. Based on the problem statement, then based on our problem, we will actually try to identify, is there any is there any model available, either it may be ML based model or Gen AI related model that is already available for me, where that model is fulfilling my task. So like that, is there any model is available for me where that model actually fulfilling my task? So such a type of models, are there any available for me in market? That we will try to identify at first. For me, let's say I have the model, I got a model where it can achieve my task and it is already available in the market. Then we need to select that model. We need to select that available model. And then we actually need to test that model. We actually need to use that model and test that model. If that model is working very good, then we need to deploy it. Then we need to deploy our model for our business use case. So till here, the life cycle is not ended. Till here, the life cycle is not ended. You need to monitor the model as well. After deploying, we need to monitor the model, and we need to debug the model, and we need to update the model each and every time whenever we need we need an update based on our business problem, and whenever based on the market scenario and based on our clients, we need to update our model day by day. So monitoring not only comes with the particular features update, it also focus on multiple aspects like security and how your model is responding to the given input. That is your response. The model response is biased to some persons, some some candidates. If our model is biasing to some persons, then whether our model can able to explain the reason why it is biased to only those candidates. So that explanation part is also related to this monitoring case only. This is all the case when we have already available model available in the market. Let's say we do not have any ML model that satisfies our business case. Then what is the scenario? During that time, we need to create our own ML model. What we need to do? We need to create our own ML or GenAI related model based on our business use case. Now, at this stage, how many ways do I have to create a model which satisfies, which exactly fit for my business problem? We actually have in this stage, we have two options. One is building a model or creating a model from scratch. From scratch, building a model for your requirement. And the another option is there are general there are already general purpose pre-trained models are there. We have general purpose pre-trained models are there. We can even use them. We can create ML models or we can use those general purpose models and we can create our ML models by just fine tuning them. That is again training them with the required data set. if we choose if we choose this path other than creating our model from scratch, then we can take an advantage of already available model with some knowledge. So that knowledge we would not need to provide, that general basic knowledge that we need not to provide if we choose this path. Or else if we choose this path, then we might need to provide some a lot of compute for creating our model, and we also require some storage and other concerns also we will face in this stage if we choose this stage. Or else if we choose this, then training our model with general data, so that burden will be overcome because the available model is already trained with some general data. And from then we just need to specialize the available model with our data set. Already general purpose model is we have, we just specializing that model based on our problem statement by providing our data set. If we choose this type of, if we choose this stage, if we choose this path, so that we call it as the way of the way of training, or the way of again training a pre-trained model, we call it as fine tuning. What is the fine tuning? By fine tuning, we can able to again train this pre-trained model and we can able to create our generative AI model. So what is this fine tuning, sir? We take that general purpose already available pre-trained ML model, and we also take our data set that we want to train this model, and by using this data set we just train this model, we just perform training this model, that this whole thing that is nothing but training already available general purpose model with our data set. We call it as a fine tuning. As a result of training the already available general purpose model, we will get specialized ML model for our task. So that is the model that is created. After creating the model, so again the same way, that is we need to test it and then deploy it based on our requirement. So this is the path that is followed. Now let's move this architecture this side so that the connection will be clear to us. All the connections will be clear to us. Now, if we consider, if we move in detail, like, so what data set we are using? Then here we need to again, now let's have a question. In order to train my model, in order to train any available model, so do we have exactly the same format of data set that this model is accepting? So while collecting our data, so first what we do, based on our business problem, we collect some data, right? Yes. So is this a collected data is same format as our model accepting? No, right? Yes. The data is not actually in the same format as our model accepting. So what we need to do? We need to perform some cleaning action, and we need to perform some pre-processing tasks on this data to make that data suitable for training our ML model, right? Yes. So that data pre-processing, we call it as feature engineering. So first we need to collect our data and we need to perform this feature engineering. Then after performing this feature engineering, making our data suitable for training, then only we need to pass that data set to our model for training. Okay, we have now the data set that we collected. Then after we prepare the data set suitable for training, then after I want to perform training to my model with the given data set, with the data set that I have. Now, let's say I have 100% of data set. I have, I'm considering my data set is 100%. Now, while training, while training, do I need to check, do I need to check for accuracy? That is, how much, how much my data is, how much accurately my model is predicting my output, or how much accurately my model is training, or how much loss is happening while training. That is how much accurately my model is trained, or how much loss is happened while training my model. So that I want to understood while training, that validation I want to understood while training. So how can I able to understood? By passing some data set to my model and predicting how accurately I'm getting response, and how much loss I'm getting while predicting the response, while the model is predicting the response, right? Yes. So those validation scores I need to observe while training. That means for training, I need some percentage of data set. So in this 100%, I need some percentage of data set for training. While training, in order to check the matrices like accuracy and loss, that is in order to check the validation status, validation of our training model, we need some percentage of this test data in this 100% data set. I need some percent for training, some percent for validation. After creating my model, after training my model, do I need to test my model? Yes, we definitely need to test our model. That is how much accurately or how the response will be. After training, also we need to test our model. For that testing also, do I require some data set? Yes. So in this 100% data set, I need some percent of data set for this testing as well. While training, in order to perform evaluation of validation of our model, we need some percent of the data, and after testing also I need some percent of data. While training, I need some training data set as well. So in this 100% we need to split it. So for now, for general purpose, I'm specifying 70% of the data set I want to use for training, 15% I want to use for validation. While training my model, I want to use 70% for training, 15% for validation, and after generating my model for testing, I want to use 15% of my data set. So I need to split this data set again into training data set, validation data set, and testing data set. So while training my model, I need to train, then after I validate my data set. After training my model got created. I need to test my model with that test data set. If we again see in depth here, then testing will becomes one part here, and then again deployment comes to another. So since these are again two parts, let's split that, like testing is one part, and then deployment of our model is again another part. Then after we need to perform this monitoring, right? Yes, testing our model and deploying our model and monitoring our model. So in this testing part, so only testing will be happened, or any other things will be happened in this part. So basically this is this testing and evaluation all comes under model evaluation part. Model evaluation part. That is, we are evaluating whatever the model that we get as a result. Whatever the model that we have, that we are validating or evaluating that. So there we will get a testing part, as well as we also get accuracies, or we will take the matrices to, we will take multiple matrices to actually evaluate our model, right? We will test our model, we'll get some matrices, and we'll evaluate our model. Now if we take a overview of all this thing, or if we frame this into correct format, like, so till here, this is the data part, right? Yes, we are collecting the data, processing the data, and we are making the data set. We are again splitting the data. So that means that this all comes under data part, right? Yes. Now, if we concentrately observe this ML lifecycle, so first we'll collect the data, we'll do feature engineering, and we create the data set. Then we'll split the data for training, validation, as well as testing. Then we will use the training as well as validation data set while training, and we will identify the validation data set, like we'll identify the accuracy. So after we get the model, we again need to test the model with the testing data set and get some matrices. So after that, we will choose whether we need to deploy that model, or we will again need to fine tune that model. If we again need to fine tune that model, then we again fine tune that model with some more data, and we'll make our model to be best fit for our business need, and fulfilling model that best fits for our business case. So like that, we'll actually train our model. Then after, if the model evaluation matrices, or we satisfied the model evaluation matrices that we get, then we deploy that model, and then we will monitor that model. Now let's classify these ML stages. Here totally we are working on data, right? Yes. So can I say this is stage as data stage? Yes. Here if we observe, we are doing a training of our model, and we are evaluating our model, right? Yes. So this is related to code. Yes. Training our model, that is fine tuning our model, as well as a model evaluation, as well as model deployment. So these are all related to code. So that's why we can call it as code related aspect. So coming to monitoring or maintaining the model, like so if the model is not up to date, like if the model is not satisfying user experiences, then we need to again again we need to update it, right? Yes. So we need to, like that, we need to actually we need to maintain the model. So here model aspects came. So what are the model aspects? Nothing but we need to monitor our model, and we need to check whether that model is best satisfying our business cases, our client satisfaction. If not, we will again make this model reliable, and we will redeploy it, and we will again monitor it. So that stage we can call it as a model stage. We can perform the same action repeatedly. We'll fine tune the model again, and we will deploy the updated version, and we'll again monitor. So based on current update, we again fine tune that model, and so like that the process is continuous. That stage we can call it as a model stage. So like that, we can classify this ML life cycle into these three stages. These are different stages, right? Yes. So if we classify this ML life cycle into different stages, we got these stages. Data management stage is there, code management stage is there, and model management stage is there. If we consider the roles or the associates or the engineers in real time, which job roles are responsible for performing these tasks, for maintaining this ML life cycle? So what are the, or GenAI life cycle, what are the roles are required for managing this data? So like data collecting and data pre-processing, some part of data pre-processing. For that case, data engineers are required. Then, in order to extract the specific features, and in order to train the model, and in order to deploy the model, we require data data scientists. We require data scientists. Then, after deploying our model, here comes the model evaluation. Who will take care of the model evaluation? Like the model is biased or not, that governance or that model approver, whatever the model that we created, that model approver will be taken care by some other roles, that is model approvers or governance officers will take care of it. And in some case, so during the model maintenance, we need to perform some automation tasks, like we need to repeat the same task again, and we need to get the latest data set, and we need to train our model automatically and perform CI/CD pipelines. So ML code maintenance and app related automation. So such a task we actually need DevOps engineers, right? Yes. So for automation purpose, CI/CD purpose, we need DevOps engineer. And if we concentrate here, this is related to ML tasks. So we need some roles or job which have familiar idea with this ML, as well as DevOps also. Such type of requirement is also there in the market nowadays. So such type of roles we call it as ML ops engineers, ML ops engineers. And this becomes the upcoming trending market nowadays. Now, if we wrap up this whole data into simple content, like if we see this whole ML lifecycle into a simple content, then can we say this all related to process, this is stages, as well as this implementation part comes under process? Yes. So this is all process. So what are the job roles? These are nothing but a people. Yes. So in order, these people will implement these process. So these people, in order to implement this process, they require some platform, right? They require some technologies, right? Yes. So in order to implement any ML life cycle, we require these three things. One is people, and what process they'll implement, that is the people with highly skilled persons to implement these processes all that people need to know in order to implement this ML lifecycle. And in order to implement this ML lifecycle, they need the technologies. Then what are the technologies that are available in the market? We have multiple cloud providers are there. They are actually providing us multiple ML management, ML lifecycle management tools are there. If we take famous cloud providers, then AWS is providing us the platform, that is a SageMaker. There you can able to fine tune a model or build a model from scratch as well. Not only SageMaker, AWS also provides us this Bedrock where we can able to directly use already available pre-trained or already available foundational models from this Bedrock. These two services related to AWS. If we focus on Google, then it is providing us Vertex AI. There we can able to use Google Google related generative AI studio notebook. There we can able to develop our model from scratch or fine tune our model as well. Here in SageMaker we can able to do that. Whereas in similar to this, Azure is also providing AI studio notebooks. Like this we can able to build our model from scratch. So for that we have multiple famous cloud providers providing services already available in the market. Not only just building for CI/CD, for automation, for MLOps engineering or DevOps as well, for automation purpose as well. AWS is providing us the services like SageMaker pipeline is there, and we also have AWS related step function state machines that we can able to create in AWS step functions. By using that, also we can able to perform this life cycle. These two are related to AWS. Not only these, we also have open source technologies like we have Apache Airflow, and we also have Kubeflow. We can able to use these technologies in real time. These are open source technologies, these two. So like this, we have multiple open sources are also there, as well as premium services or premium technologies that are provided by some famous Google or some famous cloud providers are also there. So we need to choose any one of these, and we can able to implement this ML lifecycle. So this is the top level view of this ML lifecycle, where it involves people, these people, and it involves implementation of these processes by these people. And on top of these technologies, these are just some examples. In real time, we might have a lot number of technologies are there. By using these technologies, these people are implementing this ML lifecycle. So this is a overall in-depth overview of ML lifecycle or GenAI model lifecycle. I hope you understood this life cycle and you got a good knowledge regarding this implementation or process or people or technologies involved in this ML or GenAI related life cycle. I hope this video is useful to you. If you feel this video is useful, then please like, share, subscribe, and hit the bell icon to get the latest update. Thanks for watching again. See you back in the next video with another interesting topic. Until then, bye bye, guys.